Hello, this is Mr. Best. Welcome to homework 3-39 through 44. For each of the shapes formed by the algebra tiles below, we want to sketch and label the shape on your paper and then write an expression that represents the perimeter. And then we want to make sure we simplify that perimeter expression as much as we can. So on part A, you have one unit, x, 1, y, 1, x, 1, and on the other side you have the same thing. So we just want to find the perimeter for that. So we can write it all the way out. I'm going to go ahead and add it as we go along. I see that there's 4 x's. So the perimeter is equal to x added 4 times, which would be 4x. I also see there's 2 y's, so that'd be plus 2y. And then you have 1, 2, 3, 4, 5, 6 1's. So that's plus 6 there. So that's the perimeter of A. On B over here, you can see that you have 1, x, 1, 1, 1, 1, but then we have somewhat of a problem right here. We don't know what that one is. So we can do this a couple of different ways. I think maybe the easiest way to potentially see this is to kind of expand and make that a true rectangle. And so now when you look at it, you have x, and then you still have the 1 and the 1. This side is x, and then 1 and 1 as well. So if you look at that, I can kind of show you here. This 1 represents this 1. Okay, this x represents this side right here and this piece right here. Kind of hard to see, but once again it represents this side and this side. That's what that x represents. So then if we add all those up, the perimeter is equal to 2x plus 4. So we'll get to see this again on part C as well. So on part C you have y, this side is x, this side is y, this side is y, and then once again we're going to kind of extend this out here, and so you have a 1 here, a 1 here, and then this whole distance right here, alright, is x. This whole distance across here is y. Okay, and so that will cover this side. It's kind of hard to draw on here to show you, but this side, and then the y will cover this side, and then this side as well. Alright, so what do we have here? Well, we also, let's not forget about these other 1 units. So we have 1 here, but then we have on the inside 1, 2, 3, 4, I think there's 6 of 1, 2, 3, 4, 5, yeah, 6 1s there that you have to also include. So for part C, the perimeter is equal to 4y, 1, 2, 3, yeah, 4y, and then you have 2 x's, and then you should have 1, 2, 3, 4, 5, 6 1s. So that's the perimeter for part C. And then part D, we'll kind of do the same thing again. So we have this is x, this is 1, this is x, and then you have 1, 1, 1. This is y, 1, 1, 1. And then we can kind of extend this out again. And so this whole thing across here, which we already know, is x. And so instead of using the x and the 1 right here, I'm actually going to take those off, and I'm going to use this whole thing and represent it as side y. And then that way that gets me this little edge over here. So it'll get me this piece, and then all of this. And that should give me the whole thing. So that leaves us with the perimeter for D to equal, how many x's do we have? 2 x's plus, it looks like 2 y's, And then how many ones? 6 ones. And that's how you can find the perimeter. That's one way to do it. Question 41, consider the rule y equals 1/2 x minus 4. Without graphing, find the x-intercept. Now remember, the x-intercept is when y is equal to 0. So we can plug 0 in for y and do this without graphing, and then solve for x. So we add 4 to both sides, multiply both sides by 2, and you get x is equal to 8. So that means our x-intercept is 8, 0. Now make a table and graph y equals 1/2 x minus 4 on the graph paper. Now we don't really need a table to do this. We've done these enough now where hopefully we can use the slope and the y-intercept to graph. But if we create a table, we can pick values of x. Now if it's going to get multiplied by 1/2, I want to pick values of x that are not going to give me fractions. So I'm going to just say -2, 0, 2, 4. And so if I plug -2 in, I get -1 minus 4. If I plug 0 in, I get 0 minus 4. Plug 2 in, 1 minus 4, and you can see how the rate of y is changing. And if you plug 4 in, you get 2 minus 4, which is -2. And so we can graph those points: -2, -5, 0, -4, 2, -3, and 4, -2. And so I can go ahead and graph the best I can without a straight edge. And then part C says, how could you find the x-intercept with your graph from part B? How would you find it with the table? So just to kind of talk through this, how can we find it from our graph? If I extend it far enough out and I can kind of use that same slope, it looks like it intersects right here at 8, 0, which is what we came up with algebraically, so that looks good. And then how would you find it with a table? Well, with a table, we would have to continue to pick values until it got closer to that y-axis. So if I plugged in 6 next, I would get -1, and then if I plugged in 8, I would get 0. So you can see where you would find it on the table as well. On question 42, we're going to evaluate each expression for a when a is equal to 2/3. So I guess we're just going to say 24 times 2/3. And you can think of this as 24 over 1. So that's 48 over 3. Or you can cancel and get 8 times 2 is 16. For B, it's 3 times 2/3. You can do the same thing here as well. You can multiply across or cancel your 3's. So the answer there would be 2. C is 2/3 divided by 0, which is undefined. You cannot divide by 0. And then D, 0 divided by 2/3. You can take 0 and divide it by a number, and it is equal to 0. 43, we have a multiple choice question. What is the slope of the line that goes through the 2 points? So we can just calculate that, and then hopefully it matches up with one of our 4 values here. So to find the slope, we got the change of y over the change of x, 10 minus 4, and -7 minus 1. And so we get 6 divided by -8. You reduce that by 2, and that's -3/4. So that looks like the answer is B. And then the last example here on 44, we are simplifying the expressions below. Looks like we're doing some multiplication and some addition here. So on part A, 5x times 3x, you're multiplying, so 5 times 3 is 15, and then x to the first times x to the first, you add the exponents, so that would be x to the second. On B, you're adding 5x plus 3x is 8x, you're combining your like terms. C, once again, you're multiplying again, so 6, and then x to the first times x to the first would be x to the second. And then on D, you have 6x plus 1x, so that should be 7x. So that is it for that section of homework.